There we go, we're recording. Okay, so section 3.1. So we're talking about in section 3.1 inverse trig functions. Okay, inverse trig functions. Now, before we actually talk about inverse trig functions, we got to talk about functions. Then we got to talk about if a function has an inverse or not, whether the function has an inverse, whatever the heck that is. Okay, and I'll be honest, I don't know if we covered it in Algebra 2 or not. It might have been something that we didn't have a chance to cover because of the lockdown. But if I was to give you this, I would just watch here for a second. Okay, this is just review from Algebra 2, whatever. And then when we get into it, I'll not tell you what to do. I hate it when teachers say, write this down, don't write this down. I think you got to be smart enough to figure it out. But still, there's certain things that you don't really need to copy down. There's certain things you definitely do. So I'll just watch here. If I give you this right here, if I give you that right there, is that a function? It's a graph. Is it a function? Yeah. Why? Anybody know?
Are all graphs functions?
Ooh, not all graphs are functions. If I give you this right here, that is not a function.
Is it because it touches the x and the y-axis once?
That's a good guess. That's not it though. No. Okay. If I give you something such as this, is this a function?
Is it because it can have multiple?
Is that a function first off? Hang on. You better say yes. Specifically, it looks kind of like a what kind of function? Sine function. Okay, that's a sine function. What?
Because it can have like multiple, like you can do that again or whatever. Like you can,
No, it doesn't have to even be repetitive. No. It's a test. There's a certain test. Don't remember that. Vertical line test. Did I ever talk to you guys about that or not?
Mhm.
Vertical line test, okay? It passes. This passes a vertical line test. Why does it pass it? This vertical line hits it in one spot. One spot. One spot. Anywhere I draw a line, a vertical line, it touches it in one spot. This one, that failed it. It hit in two spots, okay? So in order to be a function, it has to pass a vertical line test, okay? It has to pass a vertical line test. Now, they talk about inverses, okay? An inverse function. What an inverse function looks like is this, okay? If I give you y equals 3x plus 1, that's a function. That's a line, okay? And the inverse, and you guys are going to help me out here. I'm trying to remember if we covered this or not in Algebra 2 last year, okay? The way you find the inverse of a function is, I would write this down. What did I do? Switch the variables. We switch x for y. And then you either solve for x or you solve for y. Which one do you think you do? You think you solve this for x or you think you solve it for y? And let me give you a clue. You're not done. We're not done with this problem, okay? So you solve for x or you solve for y?
You already have x.
So if you solve for x, what would you still have to do? Okay, but listen what I'm saying. If I told you, we're not done with this question. If I told you to solve this for x, what would you have to do?
Find out.
No. I want you to get x all by itself. So what would you have to do?
get rid of x. Replace x.
What'd you say? Why?
Because x
I already
equals.
have
X is already by itself. So do we solve for x? No, because you'd have to do nothing. What did I just say a couple times? We're not done with this problem. So you solve for y. If you do that, you have x minus 1 equals 3y. Divided by 3, divided by 3. Oh, is x minus 1 over 3. These are inverses of each other. And here's why. An inverse will undo what you did. Okay? So, like for example, if I gave you a number, for x, what's the first thing you do with it? If I give you, say, x is 5, what do I do with 5? Plug it in and then do what? Times it by 3, then what? Add 1. If I plug in a number for x, what's the first thing you do? Subtract 1, and then divide by 3. So, somebody give me a number between 1 and 10. I don't care what it is. 7? Okay, we're starting with number 7. Times it by 3. 21 plus 1. 22. Take away 1. 21 divided by 3. It undoes what you did. Okay, if that's a word, undoes, okay? What would be the inverse of putting on your pants and then putting on your shirt?
Taking off your shirt.
Taking off your shirt. Could I say taking off my pants and then taking off my shirt? Is that right?
Sure.
You had to do the exact opposite in the reverse order, okay? So, putting on your pants, putting on your shirt, the inverse would be taking off your shirt, taking off your pants. it gets you back to the start, okay? So if you're getting ready you're ready to go to school, okay? You just get out of the shower, okay? And all you got is your underwear and socks on, okay? Well, you put on your pants, you put on your shirt. Well, if you want to get, you're like, oh, I don't want to wear that. You take off your shirt, take off your pants, you're back where you started, okay? It will undo what you did. That's what an inverse is, okay? It will undo whatever you did, okay? So, what we need to understand though is this, okay? Not all functions have inverses. Not all functions have inverses, all right? So, for example, this is something I'm not talking to you about, but I'm going to give you a little clue here, okay? Why was this a function?
Vertical line test?
It passes a vertical line test. Does this pass a vertical line test?
Yeah.
Yep. It always hits it in only one spot, okay? This failed the vertical line test, okay? So, what I want you to understand is this. Is that a function? And I'll tell you right now, this looks like it's going straight up. It's not. It's still going out a little bit, okay? Because if it was going straight up, it wouldn't be a function. You understand why? If it was going straight up and down, it would fail the vertical line test on that spot, okay? So that is a function. This is definitely a function that passes the vertical line test. This one has an inverse. I haven't told you why. This one definitely has an inverse. That's a function, and it has an inverse. I would just watch. I wouldn't have copied this down right yet, okay? If I give you this right here, that's definitely a function. You should know that. It passes the vertical line test. It doesn't have an inverse, though. There is no inverse. I didn't tell you why yet, okay? I want to see if anybody can figure it out. If I give you something like this, I don't know.
Wait, did you win this at the center too?
I'm sorry?
I'm asking the other
Oh.
center kid.
That's a function, but it has no inverse.
Does it have to go in both directions, like up and down?
Oh, that's a good guess. No. Oh, I'm trying to think. There's more to it than I'm looking for a different response. I got to think right here. I don't know. I'm gonna have to get back to you on that. I don't know. Nobody's ever asked me that. I don't know. Was your hand up?
If you like flip it, it's the same, it stays the same.
That's a good guess.
Flip that one.
Yeah. That's all right. That's not the reason though. That's coincidental by the way I drew those. That's a good guess though. This one has no inverse. If I give you this right here, that has no inverse. Okay. Now I'm going to give you a clue again. I already said it once. I'm going to see if you guys can figure this out. And I've never what I'm looking for you to say you've never said before in my class. Okay, but I'm hoping somebody will find it. We said these have function. These are functions because they pass the vertical line test. Okay. This is a function. It passes the vertical line test. Doesn't have an inverse though. Okay. This one passes the vertical line test, but it does have an inverse.
This has something to do with a horizontal line?
Has everything to do with that. Have you ever said horizontal line test before?
No,
No.
but if you do it on that, it has one
Okay.
point.
This passes a vertical line test. It's a function. And it passes the horizontal line test because it has an inverse because it passes what's called the horizontal line
It's only
test.
at one point on it.
This one right here, right. This one passes the vertical line test.
No,
It's a
it's
function,
not.
but it fails the horizontal line test. It doesn't have an inverse, okay? Same with this one. This one, it passes the horizontal line test. It passes the horizontal line test. Oops, bang, 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 bang. Man, it failed big time there, okay? So it doesn't have an inverse, okay? So what I want you to understand is this. In order to be a function, it passes the vertical line test. In order to have an inverse, it has to pass the horizontal line test, okay? So, based on what I've just told you, this right here is or is not a function right here, this one I'm pointing at. It is a function.
But it doesn't have an
Hold that thought. Does this pass the horizontal line test?
No.
No, it doesn't. What do you say this looks like? What kind of a function? It's a sine wave, okay? So, we're saying sine doesn't have an inverse. Based on what I've told you, you should be saying, yes, sine doesn't have an inverse because it fails the horizontal line test. It doesn't have an inverse.
But
What's the name of this class? Trig, FST, trigonometry. Sine is a trig function. What's the title of this section? Inverse trig function. So based on what I've told you, you should say a sine function, a trig function, a sine function doesn't have an inverse. But That's what this is all about, inverse trig functions. So do trig functions have inverses? Yes, but we need to kind of tweak it a little bit, okay? So here's what I want you to jot down. Well, just keep watching for a few minutes, okay? This one right here, we said that it doesn't have an inverse. Why?
Doesn't pass the horizontal.
Doesn't pass the horizontal line test. But what I want you to understand is this, okay? This is the square function, y equals x squared. That's what it looks like. Y equals x squared is a parabola. You should know that one from algebra 2, okay? What is the inverse of squaring something? Square rooting. So wouldn't you think that squares and square rooting are inverses? They cancel each other out? Yeah, okay, but what we need to do though, and they don't always cancel each other out though. They don't always cancel each other out. And here's why. If I take a number, and if you square it and square root it, you might think, well, you get back to where you started. Not always. Like for example, if I take 5, square it. What's 5 squared? 25. Square root 25. We're back where we started. How about 3? Square it. 9, square root it. 3. It always works. Take -4. -4 and square it. 16, square root it. 4. Did we get back where we started?
No.
It was supposed to be -4. How about that? If you might thinking, oh, well, okay, whatever. If you have negative numbers and you square them and square root them, you don't get back to where you started. You get the opposite, okay? How about this one? What if we work the other way, square root it and square it? How about 100? The number 100, square root it. 10, square it. What do you get when you square that? 100. We're back where we started. How about 36? Square root it. 6, square it. 36. Well, does it work that way? How about this? -9. Square root it. It's not 3. Why isn't it 3? Because 3 times 3 is 9. Square root -9. Not 3.
81.
Square root it, not square it.
It's imaginary.
-3. No real number.
Right now? Focus, right there. Bye. Sheila, you need to grab your stuff with the office real quick. So what do we say when we square root -9? It's what? No?
It's imaginary.
It's imaginary. Remember the square root of a negative? Did we talk about that in algebra 2 or not? Help me out here, guys.
Talk about imaginary.
Square roots of negatives are imaginary numbers? Okay, so what I'm getting at though is this. They don't always, how about division, multiplying and dividing? Do those always cancel each other out? Almost always, not always. What's that one number that screws things up a lot? Not negatives necessarily. That's a good guess though. 0. If you times by 0, what's the inverse of timesing by 0? Dividing by 0. And what happens when you divide by 0?
It's undivided.
You can't divide by 0. You're not allowed to. Now, if you've never had any before, a lot of students, like, if I give you 8 divided by 0, it's not 0, okay? The reason is, 12 divided by 3 is 4, because 3 times 4 is 12. Is 8 divided by 0 0? No, because 0 times 0 is not 8. 0 times what gives you 8? Nothing. 8 divided by 0 is not a number, okay? It's undefined. So not everything has an inverse, okay? I mean, addition always has an inverse. What is it? Subtraction, okay? So, what we need to understand is this. Not every function has an inverse, okay? So, what we need to understand is, this right here we said has no inverse, okay? Because it fails a horizontal line test. It's a function, but it has no inverse. But what if I did this? Now, does it have an inverse? If I limit it or not, would that have an inverse, that graph? Why? Now it passes the horizontal line test. If we limit the function, it will pass the horizontal line test, okay? Right here, we have a sine graph, okay? Now, what I want you to understand over here is this. I erased all of this, if it was like this, okay, you said no inverse. What if I erased this much of it? Now does it have an inverse? No. How about now? No. How about now? Does it have an inverse now? Yeah, but you want to keep as much as you can, okay? So let's go back to here. Now, what if I went like that? Nope. You want to erase what you have to, but keep as much as you can, okay? So we said this sine graph has no inverse. Has no inverse, okay? Not the way it's written, but because it fails a horizontal line test. So what if I did this? Now does it pass the horizontal line test? Huh? No. How about now? How about now? Yep. So this right here was pi. This is pi over 2. But I like to have as much of it as I possibly can. Okay? If I continue this down, it fails. How can I make more of the graph, though? Yes, sir. Now, what, can I go further? No, because then it's going to swing back up, okay? So as long as I limit the domain from negative pi over 2 to positive pi over 2, it has an inverse, okay? So here's what I want you to jot down, okay? The symbol for inverse sine looks like sine to the negative first power, okay? That's not sine to the negative first. That's the symbol for inverse sine, okay? As long as the domain is between negative pi over 2 to positive pi over 2, then it has an inverse, okay? As long as it's between negative pi over 2 to positive pi over 2. I should have told you guys this at the beginning of the class here. Do me a favor. After you've written that down, grab your unit circles. And you're sitting there going, can't we say negative 90 degrees to positive 90 degrees? I like degrees better. No, every trig class deals with radians more than, they do. They use radians more than degrees. Now this is kind of complicated here, and you're going to have to know this, but here's something that we're going to make it a little bit easier that'll help you with some of your problems here. Negative pi over 2, positive pi over 2 is right here. Negative pi over 2 is the same as 3/2 pi, right? This is positive pi over 2, that's negative pi over 2. Here's what I want you to put down. The right half of the unit circle. What the heck are we doing that for? You'll see here in a few minutes, okay? Okay, so that looks like a cosine graph, hopefully, remember? Based on that, first off, is cosine a function? Yeah, I mean, it's called the cosine function, and it's the function because it passes the vertical line test. Does it have an inverse the way we've drawn it?
Not right now,
No, it doesn't. Why?
but it doesn't pass the vertical.
Doesn't pass the horizontal line test. So what if we limit the domain? So what do you think we ought to erase? We want to keep as much of it as we can.
Everything past 1 pi.
Everything after what?
Everything past 1 pi.
1 pi?
Yeah.
Okay. Now can I bring this down like it did on the sine one or not? No, it would fail the horizontal line test. So cosine has an inverse as long as it's between what? 0 and
Pi.
0 and pi. On a unit circle, here's 0, here's positive pi. What kind of picture do you think I'm going to draw over here this time? Not the right side. Which side? It's going to go from 0 to pi. Here's 0, here's pi. Top half. These are long explanations for very quick problems that you're really not even going to show hardly any work on. Okay? Last one we're going to do is inverse tangent. Okay? Now, for inverse tangent, we had pi over 2, negative pi over 2. It looked like this. Oop, that looks terrible. Shouldn't have hit that. And we had 3 pi over 2. Look like that. Negative 3 pi over 2. Okay, oops. That looks terrible. You get the point. Is that a function? It's a function. Does it pass? Does it have an inverse? No. Why? Where does it fail the horizontal line test? Everywhere. You can't draw a horizontal line and have it hit in only one spot. Okay? But if we only had, how many waves do you think you want to have? One. And it doesn't matter which one. It doesn't matter, but, and this is not like K.O.'s preference. This is what every trig book will tell you, okay? You want to have the ones closest to 0, 0, positive whenever possible. Okay, so what do you think we're going to limit it from what to what? Negative pi over 2 to pi over 2. So, is it the same as sine? Is it the same as the sine one? Almost. What I put was wrong. Look at your unit circle. It's got to be bigger than or equal to negative pi over 2, or less than or equal to pi over 2. What is tangent of pi over 2?
It can't be equal to this.
So what do I need to do to alter it? Just a real subtle difference.
Instead of just erase the equal part.
Because it can't be that.
That's the only difference between tangent.
Yep. Now again, what are we doing here? I don't get this. You'll get it here in a second. Okay, we're going to do about 3 or 4 examples and we'll be done. What kind of picture do you think I'm going to draw on this one? Same as sine, but I'm going to have open dots here. Okay. All right. So we got to get very basic here. Very basic. This is going to be so basic that some of you are going to struggle with this. Okay, and that's okay. And I'm not going to move on until somebody can tell me exactly. I'm going to be as basic as possible. Okay. And a response of looking at the unit circle is not good enough. That's too complicated for me. Okay. What I'm getting at is this.
It's too complicated?
Too complicated. Okay. If I ask you for the sine of 45, okay, I tell you what. No, it's not too complicated. It's not specific enough. Okay, that's what I should have said. If I gave you that right there, let's do this. What is the answer to that question? What is the answer? You can look at unit circle. What? It's radical 2 over 2. Now, and up until now, I said, how did you do it? Oh, I looked at the unit circle. Do better than that. You looked at, okay. You looked at your unit circle. Okay, can I borrow this? Okay. I'm looking at his unit circle paper. I don't see
You
it.
have to actually look at the graph.
So what do I gotta do?
Flip it.
Okay. There's a lot of stuff on here.
You gotta find it.
Find what? What? What information did I give you?
Degrees.
I gave you the angle in degrees, and I asked you for what? The sine. This is so easy that some students struggle with it. I gave you the angle, and I asked you for what? For the degrees. Degrees or no, not degrees. Whoa, no, not degrees. I asked you for the sine. Okay. I gave you 45 degrees. I asked for the sine value. Okay. If I gave you this right here, what did I give you?
The degrees.
I gave you the angle, measured in degrees, and asked you for what? Sine? I asked you for tangent, okay? I gave you the angle, and I asked for the trig function. In this case, I asked you for tangent, okay? So what I'm going to ask you is this, and if you don't get this, we're going to do like 3 or 4 examples, and we're going to be done, okay? If you don't get it today, it's really okay. It'll be okay. If I give you this right here, now, what that says, now just watch this. I wouldn't write this down, okay? Just watch. At this point, I would just watch. The only thing I really wanted you to write down today was this. That's the main thing I wanted you to do, okay? And then look at your unit circle. Please don't say sine to the negative first power 1/2. I know that's what it looks like it says. You need to understand that when it looks like to the negative first power,
Inverse.
that's the symbol for inverse sine, okay? Now, if you can say, okay, inverse sine of 1/2. The way you read that is the inverse sine of 1/2. What that is saying is this. We're working backwards. Up until today, I would give you an angle, ask you for a trig function.
You're asking for
What do
the-
you think I'm giving you here?
You're asking for the trig function.
No, I'm giving you,
Trig
I'm
function.
giving you the trig function
You're asking for the angle.
and asking for the angle. Okay, what trig function am I giving you?
Sine.
Sine. So this doesn't say, this says the sine of 45. You know what this says? Not the sine of 1/2,
What is-
sine, huh? What about sine half? You listen, I'm very
What
key.
is it?
Huh?
What is sine of half?
No, not sine of half. Don't say of. You can't say of. Not sine of a half.
Sine.
Sine, it's 2 letters. Not of a half. Sine is 1/2. Sine is, I'm telling you sine. Sine is 1/2. What am I asking you for?
The inverse.
Not the inverse. I'm asking for the,
Angle.
I'm giving you, instead here it says, here's the angle, tell me the sine. Here it's, here's the sine,
Tell me the angle.
tell me the angle. We're just working backwards, okay? Now look on the unit circle. There are 2 spots on your unit circle where sine is 1/2. What are they?
60 degrees.
60 degrees and, oh, not 30 degrees. Oh, wait a minute.
It's 30 degrees.
30 degrees, not 60 degrees.
Oh, yeah.
30 degrees and what?